Gav, you alright, mate?
How you doing, man?
Good, mate, good. So,
No, all right. Let's have a wee introductory talk about some of the stuff. Right? No, absolutely. Yeah, well, I think it's really important. I mean, you've been talking about this differentiation between visible space and physical space, right?
yeah,
And we've been talking about this now for quite a few years, and that is for me the how shall I say the necessary distinction that people have to make if they want to really discern what's going on.
yeah,
Because if you don't make that distinction between these two different kinds of geometries or these two different, how should I say, perceptions that we have, right?
yeah,
Then you can't talk properly about images, about proof of things
yeah,
that are quantifiable in your world, right?
yeah,
So, and that is definitely one of the things that not only do all the proponents in this whole fight, let's call it, right, the Globers, don't discern properly, but it's also a big problem in academia generally, that you won't find propositions, theorems, real research and study in what visual space is. You won't find that in any of the physical sciences. You will find certain research topics in psychology, right? And in those kind of domains,
yeah,
but you won't find anything when it has to do with natural physics, right?
yeah,
You have to ask yourself, well, why not? Is the ball in my eye not a part of nature, right? Is the way I see not an extremely important part of what I perceive, what I quantify, what I take for granted in this world, right?
yeah,
So, why is that topic not being properly discerned?
yeah,
For me, it is the bigger topic. Perspective is a small part of that, right?
yeah,
Parallax is a part of that. Astronomy is a part of that.
Yeah.
Navigating on a ball is a part of that. Surveying, leveling,
Yeah.
all these things have to do with our correct interpretation of visual geometry,
Yeah.
right? And knowing that it's different from a physical geometry.
Yeah.
So again, I can only ask all these proponents out there, when they come to have a discussion, why are we not talking about that first principle, agreeing on that differentiation and taking it from there, right?
Yeah.
Instead of them just coming with the same tired old arguments, right?
Exactly. And I just want to add to that, because I had this kind of backwards and forwards with somebody the other day, and they were saying to me, well, they obviously understood, but they were trying to avoid, so I played the game anyway. So they were saying, well, give me an example then of how adding other senses into a visible or a visual world would make a difference. And I'm like, well, we've spoken about this before. If people just tried to construct a world without any prior knowledge, right? If they appeared in this world right now and they wanted to reconstruct something based purely on their vision, right? It would be an absolute shambles. Okay? An absolute fucking shambles. Now, what happens, the difference is that you then physically walk and move around in 3D space. And if these objects are in your 3D space, i.e. you can get to them, you can use all your other senses to formulate a fuller understanding of what they actually are. So that, again, shows you and highlights the difference. If you look at the globe, all they will ever say is, look, 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 right? Visible, visible, visible. Whereas us, we are talking about the tangible world, the world of 3D space and objects and substance, and what they actually are, how they can be quantified and what their relationships are to each other. So that's the difference.
It's also pinned down in a philosophical way as well, Del, right?
Yep.
I've said this before, I really believe that, the philosophies have a huge influence on all of our attitude, our social life, our sciences, right?
Yep.
So the philosophy of the age, has a huge influence and impact on that. So when we talk about things like direct realism, then we're talking about direct and immediate perceptions that us as sentient beings have on a daily basis, as opposed to a philosophy like idealism,
Yeah.
right? Where you're free to conjecture, to wish, to believe, to conceive of things, right?
Yeah.
That are purely imaginatory, are
Yeah.
purely ideas and concepts and notions, right?
Yeah.
Rather than being rooted in something that is direct and real, right?
Yeah.
So, people also need to make, how should I say, that distinction. I mean, maybe I'd like to...
concepts and ideas are great for artistic expression. and being creative with your imagination.
Absolutely.
But there has to be a total separation of when we're talking about objectivity. The philosophical jargon can go and ram itself. As far as I'm concerned, it comes right down to simplicity. You don't need complex language, intellects and high places to tell you that water's level. Anyone with an ounce of common sense knows that. No imagination needed, no language required.
Just to hammer this point home, and we've done this before, I have here before me a tangible object, right?
Yep.
This cigarette packet, which has a definitive form, right?
Yep.
So I know its length, its width, its breadth, right?
Yep.
I can hold it in my hand at a certain distance.
Uh-huh.
And that for me is using all my senses, right? I can hear it rustling when I move it.
Yep.
I can feel its tangible shape.
Yep.
I can understand the way it resists motion in its parts if I tried to bend it, or do you know what I mean?
Yep.
So all these things are a direct and immediate reality, right?
Yep.
But if I just put this thing down or have it here hovering, right, in space without me touching it, then all I then have is a visual perception of it. And as everybody knows, the visual shape of this object is going to change depending on its orientation, right? It can be a square, it can be, nearest damn it, a line, it can be oblong shape, parallelogram, right?
Yeah.
So, people have to understand that for one tangible physical object, it can have multiple representations in visual space, right? Yeah. Depending on how you're looking at it and what its situation is relative to you.
Exactly. I challenge anybody, based on what you have just said, to measure anything purely on your vision. You go out into the street right now, identify a building in the distance, and I want you to measure it for me with just your eyes.
Yep. And the funny thing is, Dale, if two people went out to two different places and did it, they'd come back with different results.
Exactly.
Right? So you couldn't even have a consensus necessarily on what way to build the world based on visuals, right? Yep. Because it would depend on two different people, right? And two different situations, right?
Exactly.
That being said, right, so we have the clear differentiation between what I'm going to call visual geometry or visible space and physical space. And one really important thing is the way that you quantify a measurement in those spaces, right?
Yeah.
Because if you're not discerning them to begin with, then you're immediately got a problem, right? But let's assume you do discern them, and you say to yourself, well, okay, I want to measure something in physical space. So let's say I want to measure the length of something. Yeah. Then what you try and do is you find a base unit, right? Uh-huh. You maybe say the size of my foot. So the size of Gavin's foot, right, is now going to be used as a base measurement. And I'm going to see how many times Gavin's foot, stretches across that length, right? Yeah. Now, that would be a physical measurement based on a physical unit, right?
Yeah.
Natural stuff. Now, when we go to the visible world and we want to try and do that, then we have to use the same kind of concept. So something has to be made of similar parts to be able to be measured, right? And if it's not made of similar parts, then how the hell are you going to measure it, right? If you can't find feet to go along the length, then you've got no measure, right? Mm-hmm. Now, there are attempts to quantify things visibly. And one of the things that I showed the last was the eye test, right? Which everybody is aware of. So the eye test basically uses certain figures, geometric figures, if you like. In this case, they're encased in a square of 5 units horizontally and 5 units vertically. And the idea is that, okay, I have similar parts in this figure, E, for example. So I've got the stroke width, and then I've got the so-called gap width, which is the white area. And the stroke width would be the black area. Yeah. And you can see that it's made up of, 5 parts here vertically. And it's also the same horizontally, right? So you can find a visible, or you can define a visible object. You can make it made of similar parts. And then you can go away and try and, for example, measure the limits of vision. So where exactly do the limits of vision occur? And what can we see and what can we not see properly, directly and discern properly. So, that's why this eye chart is invented, right? Mm-hmm. So that you can basically understand that okay, under 1 arc minute of space in here, this gap, this white gap, if I can no longer see that, then this whole figure turns into a black box, right? So I can't see an E anymore. So there are ways of trying to measure, for example, visual acuity, or measure the object sizes of things, but you have to be aware of the limitations of the geometry.
But that's
you can only measure angles.
The things that you're describing here are also based on tangibles, though, where you're taking a tangible, an understanding of something tangible, and then trying to formulate an understanding.
Exactly.
You know, you can't just take that what you're saying, and then then I can say to somebody, right, now go and measure a rainbow for me. You can see the fucking thing, so what? Measure it for me. You have to have something in the first place, as you were pointing at.
Absolutely, Dale, and that's why the Snellen chart, you're supposed to stand 20 feet away from it, right?
Yeah.
But you actually have to have a physical measurable distance where your eye is at, right?
Yep.
And you have to, and that has to be at 20 feet for you to have 20/20 vision, right? Yep. I mean, that's why it's called 20/20 vision, or 6/6, because you have to be at a distance of 20 feet or a distance of 6 meters in the modern parlance, right? So, and yeah, you're quite right. So you can set up a visible measure of things, but you have to start from some tangible physical reality.
Yeah.
Yeah. Exactly the point. This understanding of what is the real Euclidean space that we live in, which I've depicted here in the top left-hand corner, right?
Yeah.
And this idea of our visible space, right? So whether you're, how we actually see visible objects in our perception are very much different geometries, right? And there is research on this. And I'd like to just give you a couple examples of research on this. This one here, for example. So this is a research paper, right, about visual perception, where the people here in this research paper have basically come to the same conclusion. The binocular visual space is the same as the Riemannian space of constant Gaussian curvature, right?
Yeah.
Which is apparently the ball we live on, right?
Yeah.
So, other people are looking at this topic, and there is real research going on, but unfortunately the area and domain it's in is all psychology and behavioral sciences.
Yeah.
And it should also be part of the natural sciences as to why, if our visual perception is using the same geometry as our physical geometry of this supposed ball we're on, then I want to know exactly what these differentiations are, Dale, right?
Yep.
And it shouldn't just be left to the papers of psychologists with the help of a little bit of mathematics. I want to see the whole of natural science look into this properly, right?
Yep.
And keep it, discerned and differentiated and not mixed all in one big bag, right? Cherry picked, exactly. Cherry picked, So, I mean, this is I'm not quite sure how recent this paper is, but I just want to point out that there are, here we go. So 3 medical doctors and 2 mathematical analysts have helped, right? All 3, 2 PhDs trying to figure out the geometry of binocular. So they're talking about 2 eyes, right? Mm-hmm. But, understanding what visible space is. But there's just not enough of this research going on.
Yeah.
And that's because these people are also blind, They've never given it a second thought about water, Dale, right? Or about pressure to understand that it must be nonsense that we're being told, right?
Exactly.
So, all I want to say here is that this is not just some kind of stuff being pulled out our arses, right? It's proven science at the end of the day that our vision is different from our physical space.
Yeah.
Whether it's what kind of geometry it is, elliptic, spherical, sometimes hyperbolic, depends on a whole plethora of different circumstances, right? That we don't fully understand. But this is where the conversation has to be, if you ask me, for us all to make sense of this world.
Exactly. The tangible world is plain. It's a plane. That's what we know. That's the space we live in, and that's what we apply. Now you've got this cult trying to tell you it's just like that at a local level. The curve's out there somewhere,
Well, look how easy it is to define what the curve is. I showed this the last time we were on, right? That the definition of a nautical mile, right, is set up such that the radius of the Earth, so the number of minutes in a radian is equal to the number of nautical miles in the radius of the Earth, right? So this 3438 nautical miles is exactly the radius they tell us that we're living on, right?
Yep.
But it's also the same formula and the same mathematical tool that's being used to describe the geometry of vision, right? So you know, guys, you can't just go making those definitions and telling us that we're on a ball, right? We're not properly discerning between what visual and what physical spaces are, right?
Yeah.
And I've said this before, and I just want to make sure that this is hammered home. So when they make instruments, right, that are employed in things like surveying, leveling, and astronomy, then they are based on the principles of mathematics.
Yeah.
It's the mathematics that the choice of mathematics, the choice of geometry is what drives the creation of your instruments, because you're basically in your mathematics defining what it is you want to measure, right? Because it's the geometry that tells you how to measure things, right?
Yeah.
So we're talking about feet or inches or square yards or anything like that. That is a mathematical model, and depending on what you want to measure, you go away and you make instruments to measure it, right? So people need to understand how much influence mathematics has, and just because an instrument is providing something, well, yes, it's been set up that way to measure exactly what the mathematicians wanted to measure.
Yeah.
You know what I mean? So we need to be very careful about, you know, if I get an instrument now that shows some funny blips and bleeps on a screen, right, and I say this is my nerval cortex firing photons in my brain, right, then you have to be very careful exactly what this thing is really, you know, measuring, and what was the mathematical foundation of it, because that's what's driving this definition of a measurement of a quantity, right?
Yeah.
And that's, you know, exactly where mathematics has an immense power, right, to persuade people that, you know, that it's all correct and that it's reality, but in truth it's not.
No.
Right? Instruments are being made depending on the mathematical models that people are constructing, right? So, you know, that's where we need to be very careful and understand that mathematics is not reality.
The point of that is, you know, Gav, you're measuring from your foot. Somebody on the other side of the pond's measuring from their foot. You're a size 7, they're a size fucking 12. So the two of you get together and you try and construct something that ends up in absolute fucking shambles.
People need to be very clear about what's happening with vision, right?
Yeah.
They need to understand very clearly that direct, immediate reality and direct realism is the only type of philosophy that's going to lead you to a true understanding of the world that you live in, because that's the one that includes all the perceptions and doesn't have some kind of representative in between, right? Or some idealistic thing, right? So, you know, direct realism is the correct way to do it. And a direct realist knows how his eye works, right? And if you know how your eye works and you know the difference that visual space has to physical space, then you can see through the bullshit.
Exactly.